In this video, we'll prove that given that the limit as x approaches c of f of x is L, and that the limit as x approaches c of g of x is M, the limit as x approaches c of f of x plus g of x is L plus M. The precise definition of the meaning of the statement, the limit as x approaches c of f of x is L, is, for all epsilon greater than 0, there exists a delta greater than 0 such that if the absolute value of x minus c is greater than 0 and less than delta, then the absolute value of f of x minus L is less than epsilon. The same definition similarly applies to the statement, the limit as x approaches c of g of x is M. So we are given that we can specify as small a positive value of epsilon as we want, within which we can make f of x to L, and always find an interval around c plus or minus some delta, where f of x is within epsilon of L, except maybe right at c. Likewise with g of x and M. Let's start with the triangle inequality, which states that given any two real numbers a and b, the absolute value of the sum of a and b is less than or equal to the sum of the absolute values of a and b. Now let's substitute f of x minus L for a and g of x minus M for b. Then the triangle inequality looks like this. If we rearrange the terms inside the absolute value expression on the left, the expression inside the absolute value on the left-hand side looks like the left-hand side of the inequality at the top of this image. Now, the f of x plus g of x is like the f of x in the epsilon delta definition of the limit. The L plus M is like the L in the epsilon delta definition of the limit, and the expression on the right-hand side of the inequality is like the epsilon in the epsilon delta definition of the limit. Our job is to show that for any epsilon, represented by the expression in the top red ellipse, there exists a delta such that whenever x is within that delta from c, except maybe right at it, the inequality is true. Let's take an arbitrary positive value of epsilon. We want f of x plus g of x to be within of L plus M. Now since we were given that the limit as x approaches c of f of x is L, and the limit as x approaches c of g of x is M, for any arbitrary value such as epsilon over 2, we can always find a positive value of delta such that if x is within delta units of c, f of x is within epsilon over 2 units of L, and g of x is within epsilon over 2 units of M. We can always find a value of delta that makes both of these terms less than epsilon over 2 as long as x is within this delta units of c. If f of x is within epsilon over 2 units of L, and g of x is within epsilon over 2 units of M, then by the triangle inequality, f of x plus g of x is within epsilon units of L plus M. And for any value of epsilon, we can always find a positive delta to make it so that if x is within this delta of c, this is so. This proves that the limit as x approaches c of f of x plus g of x is L plus M. One thing, notice how near the end we played fast and loose, switching the less than or equal to of the triangle inequality as shown at the top to the less than of the limit definition as shown at the bottom. Given the limits of f of x and g of x that we were given at the beginning of the problem, we can always find a delta value to ensure that the absolute value of f of x plus g of x minus L plus M is strictly less than any epsilon. So the sum law of limits is proven.